Hello and welcome to this science lesson on mass and weight. This video lesson is brought to you by STEM Akada and my name is Abiodun. To support us, subscribe to our YouTube channel, follow us on all our social media platforms, and share this video with others. Here's what we'll cover in this lesson. Starting with gravity, we will explore mass and weight, then learn how to calculate mass and weight. So let's begin with gravity. Gravity is a force of attraction between two masses, where the object with a smaller mass is pulled by the gravitational force towards the object with a larger mass. For example, gravity exists between this man and the planet Earth and pulls the man towards the Earth. Also, gravity exists between this astronaut and the moon, pulling the astronaut towards the moon. Contrary to what you may think, gravity exists not only on Earth, but everywhere. Now, with regards to objects on Earth, the force of gravity pulls objects towards the center of the Earth. You also need to know that the bigger the mass of an object, the greater the force of gravity it exerts on smaller objects around it. Now let's consider mass. Mass is defined as the amount of matter in an object. It is a physical and measurable property of an object. The mass of an object is measured in kilogram unit with a symbol kg written in lowercase letters. As a property of matter, the mass of an object stays the same wherever you go. For example, this elephant is said to have a mass of 6,000 kilograms, while this mouse has a mass of 0.02 kilogram. I should also add that the mass of an object is measured using a device called a beam balance. Next is weight. Weight is a force. It is a downward pulling force on an object due to gravity. So weight is the effect of the force of gravity on an object. The unit of measuring weight is Newton. The symbol is N, uppercase letter N. And weight is measured using a spring balance or weighing scale. Unlike mass, weight changes depending on where you are and actually depending on the force of gravity that exists there. So if the force of gravity is I, weight will be I. And if the force of gravity is low, weight will be lower. On your screen, you can see that the value of gravitational force on Earth is 10 Newton per kilogram, while the value of gravitational force on the moon is 1.6 Newton per kilogram. This tells you that gravity is higher on Earth than on the moon, and as such, will make the weight of an object to be larger on Earth than on the moon. Now, let's see some figures. Remember our big friend, the elephant that has a mass of 6,000 kilograms? On Earth, this elephant weighs 60,000 Newton. But on the moon, the same elephant only weighs 9,600 Newton. Same elephant, different weights in different places. So how do we calculate mass and weight? To calculate the mass or weight of an object, you need to know the value of the force of gravity being exerted on the object. This is also called the gravitational field strength and symbolized as lowercase letter g. On Earth, the value of this gravitational field strength is 10 Newton per kilogram, but on the moon, the value of gravitational field strength is 1.6 Newton per kilogram. You also need to know the mathematical relationship between weight, mass, and gravitational force. That is, weight equals the product between mass and the force of gravity, here represented as W equals M times G. With this formula, you will be able to work out the weight of an object given its mass and the gravitational field strength, or the mass of an object given the weight and the gravitational field strength. Now let's attempt these three questions. Question 1. What is the weight of an elephant with a mass of 6,000 kilograms on Earth? To solve this, you will need to recall the formula and use the values provided in the question. The formula is W equals M times G. Weight equals mass times gravitational field strength. And to apply this, W becomes 6,000, which is the mass of the elephant, multiplied by the gravitational field strength on Earth, which is 10 Newton per kilogram. And what that gives us is a value of weight that is equals to 60,000 Newton. So this 6,000 kilogram elephant weighs 60,000 Newton on Earth. That is the solution to the first question. Now to the second question. It says, what is the weight of a man who has a mass of 80 kilogram on Earth? Again, you need to recall the formula. W equals M times G. Weight equals mass times the gravitational field strength. And that gives us W equals the mass of the man here is 80 multiplied by the gravitational field strength on Earth, again, which is 10. And that gives us a value of weight that is equal to 800 Newton. So this 80 kg man weighs 800 Newton on Earth. That is the solution to question 2. Now we go to question 3. What is the weight of a man who has a mass of 80 kilogram, but now he is on the moon? Now we are working out the weight of this man on the moon. The formula remains the same. W equals M times G. But now you have to use the right value of gravitational field strength. Since the man is on the moon, the value of G to be used is 1.6 Newton per kilogram. So again, the formula W equals M times G becomes W equals 80, which is the mass of the man, multiplied by 1.6, which is the gravitational field strength on the moon. And this gives us a value of weight that is equal to 128 Newton. 128 Newton. So this man weighs 800 Newton on Earth, but weighs 128 Newton on the moon because of the effect of gravity that differs on the Earth and on the moon. So here is another task. In this question, we are given the value of the weight of a man, 750 Newton, and we are required to determine the mass of the man. We are required to determine the mass of the man. Now, to help with remembering the formula for weight, arrange the three quantities in a triangle as shown here. With this arrangement, weight equals the product of mass and gravity. So you have weight at the top of the triangle and mass and force of gravity at the base of the triangle. So weight in this case equals the product of the two quantities you have at the base. Weight equals M times G. Okay, and also mass will be equal to the weight divided by gravity. Weight divided by gravity, just as arranged in the triangle. Mass equals weight divided by gravity, and gravity will be equal to weight divided by mass. So by including the division signs and the multiplication sign, you're able to recall or remember the formula and the versions of that same formula. So now we are to determine mass, and we are using this formula: mass equals weight divided by gravity. And we're working with the mass. We're determining the mass, and in this case, the weight of the man is given in the question to be 750 Newton. So mass equals 750 divided by 10, which is the gravitational field strength on the moon. And that gives us mass equals 750 divided by 10, that is 75 kg. So mass, the mass of the man that weighs 750 Newton on Earth is 75 kilogram. 75 kilogram. That is simple, right? So here are the major points from this lesson. Mass is defined as the amount of matter in an object. Gravity is a force of attraction between two masses. Weight is a force on an object due to gravity. And weight equals mass multiplied by the gravitational field strength, which is represented as W equals M times G, with G being approximately 10 Newton per kilogram on Earth. I hope you enjoyed this lesson and learned something new about mass and weight. If you have any question or want to request a lesson on a particular topic, please let me know in the comment section, and we'll be sure to respond to you. Once again, I'm Abiodun from STEM Akada. Remember to like and share this video with others. Also subscribe to STEM Akada YouTube channel and social media platform. I'll see you in the next lesson.